Hey learners, welcome back to the channel. In this video, we'll learn how to delete a node from the beginning, the end, and any given position in a singly linked list. So let's get started. So let us first understand, like if we have this as one node, this is the second node, and this is the third node. And we want to insert, we want to delete this node. Then what happens? So we know this one is head currently, and we want this to be as the head. Rest of the things remains the same. So we can simply say that we'll just go to the second node and we'll say head is equal to the address of this node. Now how we get the address of this node? So we have it stored here. So head is equal to temp dot next where this one is the temp. So basically what we did, we had these three nodes and we want this to be as our head. So we simply went up to the actual head that we have and we saw the address is stored here in the next of the head and we made that head. So basically we can also write it as head is equal to head dot next. Now let us see other cases. If we want that, again let's say we have four nodes. So again you can see that we just have to change the head, rest of the things remains the same. So no matter how many more nodes we'll have, we'll just have to do the same thing, that is go to the first, that is our head, and then just is equal to head dot next. All right, so let us take another case now. If we say that we have just two nodes, then what happens? Then again it's the same thing, we just have to go to this and head will be head not next. Okay, but if we remove this node, if we just have one node, then what happens? And we need to remove this one. So again you can see null is stored here. So if we write head is equal to head dot next, so again it will be correct because head will point to null, and this will be correct because there is no node in the linked list. But if we say that we do not have any node in the linked list and then it says to delete node at the position 1 or at the beginning, then what happens? So that is the edge case and we need to handle that separately. For that we'll say if head is already null, we'll check the condition. If head is null, then we'll just say that there's no such node, there's no node in the linked list, so simply you can delete it. Now let us write the code. So this code was already discussed in our first video. Now we're just adding the functions of delete in this one. So first we'll write node star delete from beginning. Inside this we'll write node star head. If head is equal to null pointer, then we'll say that the list is empty and we'll say to return head. Now we'll say node star temp is head and head is equal to head dot next. And also when we are deleting, like here we delete, if we are deleting this, then we should delete the node as well. Just deleting the link will work, but it will take memory in the space. So we should delete that particular node. And so that's why I'll write here delete temp. Then we'll return the head. Now let us write the main function. So here we'll write head is equal to delete from beginning. Inside this a parameter head, so we'll provide it head. And here we can print after deleting from beginning. Here we'll say display head so that we have the linked list printed. So you can see 10 is deleted from here. So what we wrote in this is, this one is normal, that is followed by all works for all the nodes, whether it is 1 2 3 or any, and this is the edge case when we do not have any node in the linked list, then this function won't work, and that's why we wrote this extra condition for this one. All right, so now let us see if we want to delete it from the end. So let's say we have three nodes, 1 2 and 3. So in this to delete the last node. So delete the last one. What we want is the second last node should have the next as null, because this contains the address of this one. So to just remove this link, we want that this should contain null. Now what we can do is, if we observe, then this have null. So if we say this to be as temp, then we know temp dot next is null, because this one is null. By this condition, what we can do is we can get the second last node of the linked list. By getting the second last node, we can just say that temp dot next should be null. And by this, we can simply say that this node will be disconnected from the linked list and we'll just have these two nodes. So let us write here, or maybe let's discuss if we have one node, that what happens those cases also. So we discussed for three nodes. If we say we have four nodes, five nodes, six nodes, it will follow the same thing. Now let's see for two nodes. So for two nodes, what is the condition? That temp dot next is null. So this one is temp, next one is this, and next one is null. So it follows when we have two nodes. Alright, if we say that we have only one node, then so for one node, if we see temp dot next, then it is already null. So if we go further null to next, then it will give an error. So it is an edge case and we have to deal it in a different way. Okay, so let's start this. So node star, and it is delete from end. Inside this, we'll take node star head, and then here first is if head dot next is null pointer, then we will delete head and return null pointer. So this is what we have written each case differently. Now, as we are writing for other, so temp will be head, and then we'll say while temp dot next is not equal to null pointer, temp will be equal to temp dot next, and then we'll delete temp dot next, and temp dot next will be the null pointer, and then we'll return head. So it's simply that when, for example, we have two nodes here. So when we want this one to be deleted, then first we'll delete this and we'll set this to be null. So this is what we have written here. But let's discuss if we don't have any node. So it's no node condition. So if we don't have any node, then what will happen? So we can check if head is null. Then we can simply print that the list is empty. So we'll say here if head is null, then we'll simply print that list is empty and we'll return the head. Now at last we'll call it here. So this is delete from end, and here, let us see the result. So after deleting from end, we got 20. Earlier it was 20, 30. So we got the correct answer. Now we see when we delete it at any given position, then what happens. So let us again consider the case of having three nodes. And we want to delete this second node. Then what we have to do is we want to set the value in this of this node. That means we want the node which is before the node to be deleted. So this is our temp, and after getting the temp, what we'll do is temp dot next. What it should have the value of this one. So that means it should have temp dot next dot next. And before this one we can delete temp dot next. So first we will delete temp dot next, and then we'll set temp dot next should be equal to temp dot next dot next. Now if we say, let's say we have three nodes, but now what we want is we want to delete a node at the fourth position, but there is no node at the fourth position. So what shall we do? So for that we have to put some conditions, and we have to see if temp dot next not next is null or temp dot next is null, like this. So we'll see for that. Now let's say if we have two nodes, then what happens? If we want to delete this one, then this is simply the end and this is simply the beginning. So we have already discussed it in delete at end and delete at beginning. If we just have one node, then and the position is 1, then simply it will be delete at beginning. And if we have any other position, then we already have discussed that we'll put some conditions of invalid position. And the last, when we do not have any node, then simply we can say that list is empty, so we'll just return the head, which is actually null. So let us write here node star delete at position, and inside this we'll write node star head, and we'll also take the position here. Inside this we'll say if head is equal to null, then we will print that list is empty and will return the head. If we say that position is 1, then we'll return delete from beginning, and we'll give head here. Then we'll make temp here, and we'll use the loop. So for loop, like we saw here we had 3 nodes. We want to delete the one at position 2, and we started with here, which is our head. So here did not want to traverse it further, so the first one was only the thing. And if we, let's say, so let us consider that we have 4 nodes, and in this we have to delete this one. So our temp should be this one. We'll first start with this. So at first this will be the temp initially, and then we'll run the loop. Then this will be our temp. So in just one iteration we got the correct temp, and position was 3. So the loop should run from I is equal to 1 and till position minus 1. I mean less than position minus 1. So basically it has to run only once here. So I equals to 1, and I is less than position minus 1. We have this condition. So let us write it int I is equal to 1, I is less than position minus 1, and like the insertion one and deletion also, temp should not be equal to null pointer, because inside the loop we are writing temp is equal to temp dot next, and if temp becomes null, then temp dot next will be null to next, and that will give us the error. Here we'll see that if temp is null or temp next is null, then we will say it's invalid position, and then we'll return head. And here we'll write node start node to delete. So node to delete is temp dot next, and temp to next is equal to node to delete not next. Then we can delete node to delete. And at last we'll written head. So we have written this. Now we have to write here in the main. So it's delete at position. So let's say we have to delete from position 2. There's a mistake in this. Okay, so in delete at position, what we want is position as well. So here we'll write 2. So it's set in valid position. It's correct because we had only one node in the linked list and we set it to delete from position 2. So that's it for this video. Happy coding and I'll see you in the next one.